Hey guys, a quick video today going over the answers for the worksheet with the NCEA questions on ionic and metallic solids. So question 1, complete this table by stating type of solid, type of particle, and the type of bonding and attractive forces between the particles. So we have sodium metal. Sodium metal is a metallic solid. The type of particle in the solid is metal cations. So you see down here, we have metal cations in a sea of delocalized electrons. So metal cations is the type of particle in the solid. What's holding these particles together, so the attractive forces between the particles, is the attraction to a delocalized sea of electrons. Okay? Attraction to a delocalized sea of electrons. These electrons aren't attached to any particular cation. They're floating around, and we call it a sea of electrons. Okay? Sodium iodide, so this is an ionic solid, because this is a cation, the iodide is an anion. When they bond together, or when they come together, it's an ionic solid. Type of particle in the solid, it's sodium cations and iodide anions. So the cations have, the sodium has given its extra electron to iodine, which has gained it and become an anion, and its sodium's become a cation because cations are positive. Now, the attractive force between the particles is ionic bonds. Okay? And it looks like this. Now, sodium metal is malleable, whereas sodium iodide is brittle. Explain these observations by referring to the structure and bonding of each substance. So sodium metal is a metallic solid. It's made of sodium cations attracted to a delocalized sea of electrons. Notice I just took everything here and put it into a sentence. It's a metallic solid. It's made of sodium cations attracted to a delocalized sea of electrons. When hit with a hammer, the sodium cations can move around and still be held together by the delocalized sea of electrons. This means that sodium metal is malleable. So you can hit this with a hammer, it can change shape. That's why you can change shapes of a metal and the metal won't break, because it's still attracted to the sea of electrons. Sodium iodide is an ionic solid with sodium cations and iodide anions in fixed alternating positions in a crystal lattice held together by ionic bonds. So I've just taken this and put it into a sentence as well. When hit with a hammer, the charges may align with each other, meaning the anions and the cations may align with each other, creating a repulsive force, causing the lattice to split. This means that the sodium iodide is brittle. Okay, that's all you need to put, and that's an excellent answer right there. Sodium iodide will not conduct electricity as a solid, but will conduct electricity when molten or dissolved in water. Explain these observations, including what is needed for a substance to conduct electricity. For a substance to conduct electricity, it needs to be able to have either moving electrons or moving ions. So you need a charged particle, ions and electrons are both charged, and they need to be able to move. So that's how it can conduct electricity. As a solid, sodium iodide is an ionic lattice with anions and cations in fixed, non-moving positions, so it cannot conduct electricity. These ions are locked in place, so they cannot move and they cannot conduct electricity. When molten, the lattice becomes a liquid, and the ions are now free to move and carry a charge. So the ions can now move around and carry a charge, meaning it can conduct electricity. When dissolved in water, the ions can float around and carry a charge and conduct electricity. So that's all you need to put, and that is also an excellent answer. Alright, thanks for watching guys.